Okay, so on page 532, I asked you to do numbers 1 to 5 and 8 and 9. So number 1, a wire segment that's 31 meters long, that's your L, moves straight up through a point of 4 times 10 to the negative 2 Tesla magnetic field, that's your B, at a speed of 15 meters per second, that's your V. And it wants to know what's the EMF. So EMF is equal to BLV sine theta, and the sine theta is going to be 90. So B was 4 to the negative 2 Teslas. L was 31 meters. And speed was 15 meters per second. And you get an EMF when you do this of 18.6 volts. Number 1. Number 2. A wire 20 meters long, L, moves at 4 meters per second, V, perpendicularly through a 0.5 Tesla magnetic field. What is the EMF? So again, EMF equals BLV sine theta, says the word perpendicular, and so angle is 90. B is 0.5 Teslas, L is 20 meters, and speed is 4 meters per second. Half of 4 is 2. 2 times 20 should be 40 volts. Number 3. An airplane traveling 950 kilometers per hour, so you do need to change that to meters per second, and it's 263.8 repeating meters per second for your speed. Where the Earth's magnetic field is 4.5 to the negative 5. So remember I told you that the magnetic field is different on different places of the Earth. So if a question tells you what it is in a particular spot, you use that amount. So 4.5 to the negative 5 Teslas. For us, it's 5.5 to the negative 5. And is nearly vertical. The voltage is induced. What voltage is induced when the tips of the plane are 75 meters apart? So 75 meters, 263.8 repeating meters per second, and you should get an EMF of 0.890625 volts. Okay, number 3. Number 4 says a straight wire 0.75 meters long moves upward through a horizontal 0.3 Tesla magnetic field at a speed of 16 meters per second. So again, EMF is equal to BLV sine theta. So EMF equals B is 0.3 Teslas. L is 0.75 meters, and the speed is 16 meters per second. 3/4 of 16 is 12 times 0.3. This should be 3.6 volts. Okay, there's a part B that says the wire is part of a circuit with a total resistance of 11 ohms. What is the current? So that's where you use V equals IR. So I equals V over R. So 3.6 volts divided by 11 ohms. I is going to equal 0.327, and the 27 repeats, amps. Number 5 says a 40 centimeter wire is moved perpendicularly through a magnetic field of 0.32 Teslas with a velocity of 1.3 meters per second. Oh, this one has an arrow, and it's because they ask you all in one step that if the resistance is 10 ohms, what is the current? Okay, so again, EMF is equal to BLV sine theta. So EMF is equal to, B was 0.32 Teslas. L was 40 centimeters, or 0.4 of a meter. And speed was 1.3 meters per second. So you get an EMF of 0.1664 volts, but it wants current, so from here we know I is equal to V over R. So 0.1664 volts divided by 10 ohms should give me a current of 0.0166 amps, or you could say 16.64 milliamps. All right, that was number 5. Number 8 says EMF of 0.002 volts is induced in a 10 centimeter wire when it's moving perpendicularly across a uniform magnetic field at a speed of 4 meters per second. Whew. This time you have to rearrange BLV sine theta for B. So B is going to equal EMF over LV. It says perpendicular, so the sine theta is 1. So 0.002 volts divided by 10 centimeters, 0.1 of a meter, and 4 meters per second. So that's like 0.02, so it's going to be a 5. The question is, where is the decimal? I think it's 0.005 Teslas. I think that's where the decimal is. And number 9 says, at what speed would a 0.2 meter length of wire have to move across a 2.5 Tesla magnetic field to induce an EMF of 10 volts? So again, you're going to need to rearrange. This time it's asking at what speed, so V is equal to EMF over BL, and again the sine theta is 1 because the theta is 90. So our EMF is 10 volts. The magnetic field strength is 2.5 Teslas, and the L is 0.2 meters. So that goes in 4 times 4 over 0.2. It's like 40 over 2, so I think it's 20 meters per second. Donezo. Okay? So those are your homework questions from the other night.